Alright, hell yeah. So before you is probably one of the hardest problems that I've tackled. And so we're going to prove this with equations of two lines. So we're going to get a line right here. We're going to get that equation. We're going to get an equation for this line. And we're going to use all variables. So this distance is halfway, so I'm going to call it A. And since it's halfway from C to D, I'm going to call this A as well. That means over here is 2A, and then right here is B. But even right there, I guess that's a proof, because these lines are parallel. These are going to be the same. Now this problem is fairly simple because you have stacked parallel lines here and parallel lines here, meaning there's a lot of similar angles. Like this angle is equal to that angle, this angle is equal to that angle, and these are reflections of each other. So booyah, these are similar triangles. You know what I mean? So if this is B, well, I mean, and then, yeah, so we're not going to get into that. What we're going to try to do, because it's fairly simple to go through that, we're going to do something kind of difficult. So we're going to set the slope of this parallelogram. You know what I mean? So we're going to come in here with a little triangle. And so hell yeah, so that's its slope. The slope is going to be rise over run. So if the slope is m, you know what I mean, just like you have a y is equal to mx plus b, just your generic equation of a line. This slope is rise over run. But if that slope is just a number, cool, you can divide it by 1 and say, hey, this is the rise, and then this is the run. Cool, so we're going to do that right here. This is kind of how you do that. If we say this is the rise of the slope m, this is the run of 1. Cool. And this has a slope of m, with and its quantity is m divided by 1. That's the slope. Cool. Now if you turn this into a triangle, using Pythagorean's theorem, this side is going to be 1 squared, so just 1 plus m squared. Cool. And this is kind of one of the more advanced things to do. This is going to be very helpful. Just I like to use this idea of similar triangles, or however you would say it. But we're going to draw that again. But I didn't draw it right. So we have a hypotenuse, and then dropping it straight down. So here's our 90. And cool, this was m, this was 1, this was square root 1 plus m squared. So what we can do with this triangle is divide everything by 1 plus m squared. So I'm going to have, and if you could see that, oh, here's, like, someone's just like, hey, how do you not, you know, like, what's one strategy you use to, like, not get overwhelmed? Well, this is, I don't want to write things 1,000 times. So if I'm going to divide this, I might just do this. This is kind of what I've been doing lately. Is I know this is something extra. Like, hey, all these 3 terms were you know what I mean, jiving. But now I'm just going to say, hey, but I could just divide this by 1 plus m squared. And then I can see that this has a value of 1. And then I'm going to divide everything by that term. Alright, hell yeah. So this would be 1. This would be 1 divided by the square root of 1 plus m squared. This would be a... oh man, this a is getting in the way. Sorry about that. This would be m divided by the square root of 1 plus m squared. Alright, hell yeah. So, and again, this length a is our hypotenuse. Cool. So if that's the case, hey, then I even know, I can drop this down. I even know this little piece right here, and then I know this this vertical distance and this little horizontal distance based on this triangle. This has a hypotenuse of 1. I can make this hypotenuse a. So we're going to do that. We're going to draw one more triangle. So hell yeah, so we're going to have a hypotenuse of a. And if I multiply this by a, I just multiply everything by a. All of these. And that's kind of, you know what I mean, pretty sweet. So we have am square root 1 plus m squared. And then we have 1 a divided by the square root of 1 plus m squared. Alright, hell yeah. So now we need you need a few things to figure out the equation of a line. One, you need to know the slope of the line. So we need this line right here. And I thought the easiest way to find this line, and I'm just going to label it y is equal to bm. And you could say that, so if I label this as an equation y bm, I'm basically trying to find the slope between b and m. But I can also say this is the same thing as y be. The equation for a line from here to L, B to L, is the same as B to M, same as B to E, and you know what I mean, any other combination. Cool. So this equation is going to have the form y is equal to mx plus b. The y-intercept, I'm going to just set that as just right here. So this is going to be 0, 0. This is the x direction, and then straight vertical. This is the positive y direction, positive x. Okay, hell yeah. So this one's fairly straightforward. Our slope is going to be our rise term, and we already found that. We said it was this. So heck yeah, so we have am. And then right now I'm going to say, hey, if I just do a square root sign like that, that's going to indicate, that's going to be the same thing as 1 plus m squared. So, you know what I mean? Going back to that person's like, how do you not get overwhelmed? I do a lot of stuff like this. This is very useful. Heck yeah. So this is going to be am divided by this square root. You know what I mean? And inside the square root's 1 plus m squared. Enough said. Alright, so that's going to be the rise. The run is going to be b plus this little thing right here, which is that guy right there. So this is the rise. The run is going to be b plus a square root like that. Alright, hell yeah. So now this comes up a lot, is we constantly want to simplify, but not oversimplify. So that's where this problem is like tricky, because, I mean, the full spectrum is cool. We're going to get this equation. We're going to get this equation. We're going to set the y values or the x values equal either way and solve for the other. So if we set, if this is an equation for this line, y is equal to something, and we're going to get an equation for y AC, which is this line, is going to be something something, you know what I mean, mx plus b. We're going to set these two equal to each other and solve for that x value, because the x value, and we basically just solve for this point right there. Cool, and once we solve for the x value, we're going to sub it into those equations, solve for the y value. So we're going to get an x and y for this point. This point's 0, 0. So then we can easily find the distance between these. It's just going to be basically this x value squared plus this y value squared. You know, in Pythagorean's theorem, this squared plus this squared, square root that, is equal to that. Now, if we want to find this length, well, we kind of need the Pythagorean theorem here. I need this length squared plus this length squared, square root that is this length. And then the whole idea, I didn't even go over the idea. The idea of this problem is just to show or prove that this length right here is twice this length. Cool. Now, this Pythagorean theorem is going to get brutal because to get this distance, I need to take, hey, this x value maybe from the origin, and then subtract it from this L value from the origin. So I'm going to take this x value for E and subtract it from this L value, or this x value for L, and then that's going to give me this distance right there. Same thing in the y. I'm going to take this y value for YE and then subtract the y value for L. And then that's going to give me this distance. And it's just going to be all in terms of variables, so that's the tricky part. But there's some cool stuff along the way that we can do. So this is very common, and we just need the denominators the same. To do that, I'm just going to top and bottom both things. And then if I do, I'm just going to come out here. I'm going to get the a term first, so a plus, b. I'm just going to try to get everything as a plus b and then the square root term as much as possible. Cool. So now I have this divided by that. That's going to be the same thing. And then see, even right here, it's just like I got so overwhelmed that so this was the rise, this was the run, so this was the m part of this equation. We still need an x, and then we still need a plus b, but we said for this equation b is equal to 0. So cool. Okay, so then I found the bottom. I rationalized. What did I do? You know what I mean? I made the bottom so I could just add those two terms. That's kind of what I did. And now I'm taking this divided by that. That's the same thing as this multiplied by the inverse. So we have this on top, and then we have a plus b square root. But, you know what I mean? So even just this symbol right here says, hey, this is separate from this little equation. But if I'm just going ahead and just multiplying this, you know, I'm going to do this little bracket. You know what I mean? I know that it's extra. You know what I mean? It's not part of the original equation. The original equation was just this, and that is that rise over run x, and b is 0. But I did have to simplify this, you know, out to the side. And then once I did, I wanted to flip it upside down or invert it and then multiply it by this term. So now these cancel. Now so this from this, like this part's out of the equation. And you know what I mean? So I'm just kind of showing you the ways that I roll, just so I don't have to write 1,000 different steps. But overtopping these things, yeah, you kind of want to make sure that when you go back to it and look at it, you kind of see the process. And booyah. Alright, so now we're going to have y bm, this equation for this line, is going to be am divided by a plus b square root. And again, square root, I'll say it one more time, probably a few more times, 1 plus m squared. I just don't want to write it. Alright, hell yeah, and I'm forgetting my x term, so this is x. And, alright, booyah. And this is just kind of a subscript. I'm not going to put the subscript on the x. Alright, hell yeah. Cool, so that's that line. And now we need this line AC. A little bit trickier. One is let's walk our way through it. So if I had y AC, I would need the slope of line AC. Okay, so how do you find slope? Slope is rise over run. It's change in y, change in x. But the cool thing is, you know, this is slope. It doesn't matter. This is what I kind of learned today, because this is helpful. Instead of sometimes, you know, if you only can do things one way, like check this out. So this is what I did. If I had a point at the origin and a point right here, this was A at the origin, and B was just 1, 1. We know the slope is 1, just, you know, equation of y is equal to x. That's kind of what we have here. But the slope between A and B would be the rise over the run. So we would have 0, 0 here. And so what are you going to do? You're going to take b. You're going to take by minus ay divided by bx minus ax. Well, let's try that. So we're going to have 1 minus 0. And then that's going to be the y value. So we went up. So this is 1 minus 0. And then this is 1 minus 0. Cool. And we get a slope of 1. But let's say that's taking b subtract a. You know what I mean? Let's do the opposite. Let's take a subtract b. You know what I mean? Just flip these around. And it's going to give you the same thing. 0 minus 1. So if my y value is 0 and I subtract 1, cool, I get a negative 1. But then the x value is 0 and then subtract 1. So cool, I get negative 1 divided by negative 1 and 1. So the same thing. So it doesn't really matter. I just need to find the difference of the y values and the difference of the x values. That's kind of one of the things that I learned from doing this problem. Is for sure it doesn't matter which value you choose first. Cool. Alright, so the only thing to keep in mind is that, hey, if this was A, this was 2A. So this hypotenuse is 2A. So if we wanted to find this vertical distance to A, it's going to be this equation, but we just have to multiply by 2. So let me just put this in brackets. There you go. So we just multiply this by 2. You know, every part about this equation we multiply by 2. So this x distance right here is going to be right here. This y distance right here is going to be this. So that's the x, y coordinates for A. Now the coordinates for C is pretty simple because we don't go any in the y and we go b in the x. So we got b 0. So you know, I mean, which do you want to subtract first? I would rather just take a subtract b, just because then I'm less likely to get messed up with the negative signs. Okay, sweet. So I'm going to take the y value for a, which is right here. So we have 2am divided by the square root. So that's the y value. And now I'm going to subtract it by the y value of b. Well, it's 0. Cool. And then I'm going to divide it by the x value of a, which is right here, 2a divided by the square root. Then I'm going to subtract it from the x value of b, which is b right there. So sweet. All right, so and that's going to be the slope, and we're going to have x. Now this has a y-intercept that's way the hell up there. So how do we find y-intercept? Well, we just need one point on here. You know what I mean? Because we have an equation for YAC as we got slope. We have x plus b, and then when we throw in this point, it's going to be 0b. So if we throw in 0 for y is equal to m, x. This x term is b, and then and I'm just going to put this in parentheses. This is the y-intercept. Cool. So don't get it confused. That's the only problem with variables when they kind of overlap. Like even this m, for the most part, is going to be the slope, even though there is a point m on here. So if I ever use like, hey, the capital M would be x, m, y, m. Those are the coordinates for this point m. Don't get it confused with the slope. The slope is what we've been talking about. So same thing here. This is the first time that we hit, well, kind of second time. Like this is a y-intercept. This b is not the same as this b. So keep that in mind. It's just a bummer that those variables overlap. Okay, hell yeah. So if I throw in this y value of 0, this x value of b into this equation, and I've already found the slope, I just solve for b. So let's do that. So if I solve for b, I would just take this to the other side. That's just going to be negative slope times b. So that's it. So if I know the slope, just multiply this times b and subtract it. You know what I mean? So let's do it. So we can do that in one go. So we have the equation for this line. Let's clean this up. Same thing. Let's clean this up. So this top and bottom, I can add these now. So I have just this on the bottom. I'm going to take the inverse, and this kind of goes away. And when I take the inverse, I'm going to have this up top divided by that. So this is another way just to kind of keep, I don't know, I got a little messy there, but hell yeah. So this 2am, these cancel, and I'm going to have 2am divided by this term right here. That's going to be my slope. So I have 2am divided by 2a minus b square root of that. Hell yeah. And this is the slope. You know what I mean? And so we're going to multiply it by x. And then we're going to multiply it by b and subtract it. So we're going to go subtract 2a. I'm going to throw the b in right after the a, just for, keep things sequential. And booyah, it's just going to be the same thing. Okay, hell yeah. So this is the equation for this line AC. And we have the equation for line BM. So now we're just going to set these two equal to get to each other. And that's saying that the y value right there, when these two have the same y value, see how the y value is just, hey, that's the y value of that point. both of these equations go through that y value. So we can set these y values. That means that this is equal to that. So I can take this equation and just put it right there. So that's what we're going to do. Okay, hell yeah. And kind of like what I think, I don't know. You know what I mean? That's the bummer about doing these things with a camera is I just want to go to blank sheets of paper. So I can maybe, we'll see what I do. You know what I mean? Because I want to kind of use as much paper as possible. Okay, so hell yeah. So I'm going to set these two equal to each other. And if I do, it's like, why do we want to do more than one step? So I'm going to, this has a negative. So I'm going to put this right here. And might as well get this negative to the other side and then subtract that. So let's do that. I'm going to write that. At least we can have one step out of the way. 2abm divided by 2a minus b square root. So that's this term is going to be equal to this term, 2am, 2a minus b square root. Yep. They're very similar, but this has a b in it. This one doesn't. Cool. And this has an x term, so I'm gonna factor that out in a sec. And now we're gonna subtract. So this term is still over there. I need to subtract it. So I got this to that side, and now we need to subtract this term right here, which is am a plus b square root. So we have this x term. Okay, hell yeah. So this is kind of where I might as well do it this way because, I mean, if I'm doing this on camera, man, like these two terms are not the same. So what I'm going to do is I'm going to call, and this is a little bit bigger and a minus, and this is not 2, and then this is plus. So I'm going to put this type of bracket around there, and this type of bracket around there, and then this type of bracket around there. And then so I'm going to say, hey, this bracket is equal to 2a minus b square root. You know what I mean? And then this bracket is equal to a plus b square root. Because I need to get these denominators the same. And the only way to do that is to multiply top and bottom. You know what I mean? I mean, you could cross multiply and then just know your denominator doubles. I mean, but basically I'm going to come in here, multiply this by one of those, and then one of those up top, and then come in here and then multiply this by that term, and then this term up top. You know what I mean? Cool. And then even right here, I can see that, hey, oh, this term is one of those terms as well. Okay, hell yeah. So, and then sometimes I like to do this. So, you know, just to make it fast, hey, I have like something, something, but I have divided by this is equal to, okay, so now I have something, something, that, minus something, something, that. Cool. Like, obviously, we're going to be able to combine those two terms. Divided by, now I just have this times that. So the denominator is now, like, the two terms can be added or subtracted with a common denominator. That's what we're doing here. Now, when I take this, I can take this to the other side, and, you know, or I can just see it's on both sides. So however you want to see that. So I can just see that it's in denominator on both sides. I can cancel it. Else, you could take this upstairs, you know what I mean, and then see how it cancels with that. So that's going to cancel nonetheless. All right, and then, so what we'd be left with, and then even just might as well take this up there. So I'm going to be left with 2abm. This is equal to 2am. This minus am that. Okay, hell yeah. And we still have this x term. You know what I mean? So we still have a function of x. That didn't change, you know, and that, no harm, no foul not putting that in. Okay, so now I can solve for this x just by getting this downstairs. So I'm going to say x is equal to 2abm. But just see how much less writing you have to do. And then these things are just algebraic, you know what I mean, products, and they're not going anywhere for the time being. Okay, so we're dividing by 2am this. See, I even messed up. So we have this divided by this chunk. So minus am bracket. Okay, hell yeah. So that's the x term. And then what are we solving for? Hey, we just said that this equation was equal to this equation, and we solve for x. So we have this x term, so we solve for Lx. So L, point L has an x term. I'll just call it x of L and a y of L. And what we did is we just solved for x of L. Okay, but now we should clean this up. We don't have to yet. You know what I mean? Yeah, we don't. We don't have to. Yeah, we can actually just throw it into the equation. We can throw this x into either equation. Obviously, we should throw that x into the simpler equation. This one's a little more complex. This one's a little simpler. So let's do that. And we can see that, hey, this ybm is am divided by, hey, this term popped up again. So that's just am bracket. So we have am bracket x. And I'm going to throw this x of L right into there. So I'm going to have am divided by bracket. And then I'm going to multiply it. But, well, let's... So this am, let's... so I'm going to have a 2 up top. I'm going to have a 2. I'm going to have an a squared. I'm going to have a b. And I'm going to have an m squared. Cool. These two terms are going to cancel. And the x is what I'm subbing in. So I have 2a squared b m squared. That term cancels, and then we just have this downstairs term. So we have 2am bracket am bracket. Okay, hell yeah. So now this is the y term. So this is yl, and might as well clean them up right now. I'm just trying to foreshadow. Alright, hell yeah. So, yeah. So we have both values for XL and YL. I don't know if they're, you know what I mean? Well, I've already done this problem. So this, going through this is trying not to make any mistakes, but I do want to talk about the only way I was able to keep my head about this problem, because I would make a bunch of little mistakes. You know, you miss a 2, you miss a negative sign, you know, you miss something, well, then you're just SOL. That's going to carry all the way through. So how I was able to do this with like finding my errors along the way is like, even right now, what the hell do we have? We have a value for this point of L and the XY coordinate for L. So what I did is I just set the slope. Well, what I did is I set the slope equal to 1, and then I set this value equal to 1 and this value equal to 1. So I think I have all this graphed out. So I set this value for b equal to 1, so you can visually see that. I set this value for a equal to 1. That means this thing is going to be way tall. It's going to be like, hey, too tall. You know what I mean? So this is 1, this is 1, and this is 1. And then I set my slope to a 45 degrees. And even doing that, this AC actually goes backwards. So I mean, let's see if I can show you this. So if this is 1 and this is 1, this is 1... 1, 1, and what happens is like, hey, if this is a 45 degrees and this hypotenuse is 1, well, this is about 70% or 0.7. So this is 0.7, and then if I go up another one, that's 0.7. So this will travel this will travel square root of 2. So my b term right here is just 1, but if I set this has a height of 2. So this is 1, this has a height of 2, and if I set it at a 45, it's going to pass c. So this AC term is actually going to go backwards. So that was my check on reality, is that I said my slope was 1, and we can even do that right here. And I said A is 1, B is 1, and slope is 1, because then, look at this, then you're just like, hell yeah. Well, looks like we have 2 right here. And what's this? In the bracket, we have 1 plus 1. So we have 1 plus 1. And what's the square root? What did we say that was? Well, this is 1 plus 1 squared. So that's just the square root of 2. 1 plus 1 is 2, and square root of 2. So, hell yeah. So this is just 1 plus 1 times the square root of 2. This is just 1 plus the square root of 2. So there you go. So in that bracket is just 1 plus the square root of 2. And what do we have downstairs? Well, we have 2, 1, 1, and then 1 plus the square root of 2. We said that was in the bracket right there. And then minus 1, 1. What's in this bracket? Well, we have, this is the square root of 2. So we have 2 minus the square root of 2. So cool. So I have 2 minus the square root of 2. Now, algebraically, that's kind of a lot, but let's at least go through here. We got 2, 1 plus the square root of 2, and then divide it by 2, 1 plus the square root of 2, and then I got minus 2 minus the square root of 2. So not a nightmare, but still even this, that's a bit much. And I get this value for XL to be 1.138. So that's my check on reality. I even have that stored in my calculator as alpha S, so we can come back to that. Now this one, kind of same thing. We have 2, 1, 1, 1. So this is going to be 2. Now, what did we say this was? This was, so this is 2, 2. This is going to be 2 plus square root 2. No, it's not. This bracket is going to be 1 plus the square root of 2. So we have 2, 1 plus the square root of 2. And then we have minus 1, 1. And we said that this bracket was 2 minus the square root of 2. All right, let's do that just to show you. This was my check on reality because, hey, I might have made a mistake here. Like even right now I might have made a mistake. So this is my check on reality for that. So we have 2 divided by 2, 1 plus the square root of 2. And it's just kind of tedious. But hell yeah, making all those 1s make this process way less tedious. So 2 minus the square root of 2. Okay, so we get this value is 0.4714. And that's whoa. Alpha t. Yeah, so that's stored as alpha t in my calculator. So sweet. So that's the values for the x value for L. So hey, this is going to be 1.13, and then we're going to be up like 0.47. Cool. And then because the next thing we're going to do is we're going to get point E. And all right, but at least we're good to go here. I am going to simplify. Should we simplify this now? I don't think we have to. I think we should simplify at the end. Okay, hell yeah. So now we need the points for E. And I have equation for YBM. It's the equation for this. So we have that. And then I know my Y variable up here. I know where Y is because that's going to be this equation, this vertical component. If the hypotenuse is 2A, the vertical component's right there. So let me write, well, and then so that is what I'm putting in for my Y value. And then I can solve for X. Okay, so hell yeah. So so let's say this Y is equal to, this is AM, and then this is this bracket X. Cool. And then I'm putting in and then I'm going to rearrange this equation and solve for X. So X is equal to my Y value times that bracket divided by AM. So that's what I did. I just took the AM downstairs and this bracket upstairs. And this bracket comes from this, this equation that we got. But I just saw this term pop up a lot. We're putting that term in that bracket. We're putting this term into this bracket. So those were kind of the two terms that I saw popping up quite a bit. And I just didn't want to rewrite them every time. And that really helps not make mistakes. Okay, so now what are we going to do? We're going to throw in that Y value right here. So I'm going to have X is equal to, this Y value is 2AM divided by the square root. So we have 2AM divided by the square root. Okay, that's this Y value. I need to multiply it by the bracket and then divide it by AM. So the AM's cancel, and this X term is going to be 2 bracket divided by the square root. Hey, so just pretty friendly on this one. And now how do I find the Y value? Well, I take this X value, and this is X of E. And I can even put this right here formally, we know what it is now. You know what I mean? Hell yeah. And just without a lot of strokes of the pen. And again, you can put the terms back in. This is 1 plus m squared. You can just visualize it in your head. This bracket is a plus b square root 1 plus m squared. Cool. All right, so if I throw this value into this equation, hell yeah, then I get y is equal to am bracket, and then this x is 2 bracket square root. Okay, so brackets cancel, and I get 2am divided by the square root. Okay, so this one was way the hell simpler, and I get 2am bracket. Okay, so now the hard part, what I thought was going to be the worst. But let's simplify this, because I mean, we're going to have to simplify it at some point, and might as well simplify it right now. So we have, so this, yeah, how should we do this? Alright, hell yeah, I'm glad I took a pause, because, hey, all these terms have an am in them, so x of L is going, so I can get rid of the am term, and that's all I want to do for now. So I have 2b bracket divided by 2 bracket minus this bracket. Okay, hell yeah. So let's see where that leads us. Let's probably do this downstairs first. So we have 2a, okay, because I need to multiply 2 into this bracket. So I have 2a plus 2b square root, and then I'm going to subtract this bracket. So I have to, now it's foiling in the negative. So I'm going to subtract 2a, but I'm going to add b square root, okay? Because, you know what I mean? It's subtracting this entire term. This entire term is two terms, a positive minus a negative. So, anyway, I mean, I go over, you know what I mean? How I like to do this, just so the negatives don't ruin my day, is I do this. Plus, this negative becomes a negative 1. This, becomes, I can do that same thing. This is 2a plus negative 1 b square root. I find this just very fascinating. Now I can FOIL this in, and you can see that this negative 1 multiplies with the 2a plus negative 1. I have that one, FOIL in this one, and now you can easily see this is negative 2a plus b. So cool. So I have, let's go back to this term. So we have 2a plus 2b square root. Then I'm going to subtract just this term. Subtract 2a plus b square root. And isn't that what I get? Subtract 2a plus b square root. Hell yeah. Okay, and now we can see that this 2a cancels that. So finally things are canceling. That's sweet. This becomes a 3b square root term downstairs. Okay, and then we divide it with a 2b upstairs. So let's simplify this. We can get rid of the b's. So sweet, I'm going to have 2 bracket divided by 3 square root. Cool. So now let's see what that leaves us. So I'm going to have, yeah, sweet. So I'm going to have upstairs, I'm going to have 2a plus 2b square root. Downstairs, I'm going to have 3. And then this isn't that term. It's just a square root. So we have the square root. And again, that square root is 1 plus m squared. And comes from, doing these slope equations. We have a slope of m, 1. So that means that the hypotenuse is 1 plus m squared. And if we divide this by that, then the hypotenuse is 1. That's where we can just set the hypotenuse as a, but we have to divide this term by that. So that's where we get these am and a divided by that square root 1 plus m squared. Cool. All right, hell yeah. So this term is simplified, and we have ax. This is xl. And again, you know what I mean? Like what did we just do? This was this x term. This is xl. This point L has an x term and a y term. We just simplified that x term, got it pretty juicy. Okay, so now we're going to simplify the y term, and I kind of want to stay on this page. So let's simplify this y term. Okay, so here we can factor out an am everywhere, and we're going to have 2abm, because I can factor out just one of the ams upstairs. And then I'm going to have 2, factored out the am now, so I have bracket minus bracket. Okay, let's do this downstairs, because that seemed to work out pretty good. We have 2a plus 2b square root minus 2a plus b square root. 2 a's cancel, and I'm left with 3b square root. I can cancel out a b up top, so I'm going to have 2am divided by 3 square root. Okay, and that is simplified now. So now I have y of L is going to be 2am 3 square root. Hell yeah. Okay, sweet. So now we can go like on our merry way. But let's get this thing, like this is the only thing that I mean, I'm going to keep this square root. This square root's always going to be the same, and it's just this 1 plus m squared. It's the only thing I really do not want to write twice. But we can get this back to normal. So so this is going to be 2 brackets. So we have 2a plus 2b square root divided by the square root. Okay, hell yeah, and I can live with that. So we're going to have xe is 2a plus 2b square root divided by the square root. Okay, hell yeah. So I'm going to I mean, I think we're basically there. Yeah. So let me rewrite these. So I have point E. So I have xe, and that's going to be 2a plus 2b square root divided by this square root. Yeah, hopefully I didn't mess that up. Yep, that's what xe is, and then ye is 2am divided by that square root term, and the square root is 1 plus m squared. Cool. And then this L term down here, so we have Lx. Where's that one? I'm sorry. I call this x of L. So we have x of L is, oh, this was probably, no, x of L is right there. Yeah, x of L is 2a plus 2b square root divided by 3 square root. And then we have yl is equal to 2am 3 square root. Now, at this part of the game, you for sure would want to double check. And the way you would do that is just set up a slope that you can mentally grasp, and then have a is 1, b is 1. So this is 2 plus 2. This becomes square root 2. So we got 2 plus 2 square root 2. So 2 plus 2 square root 2 divided by 3 square root 2. Divided by 3 divided by square root 2. So that's my x term, and that jives. We already said that was going to be alpha s. And the y term is 2 divided by 3 divided by the square root 2. And that's our y term alpha t. So this is in my calculator alpha s, this is alpha t. I even have these in my calculator. Probably as alpha n and alpha o. When I set the slope as 1, if this is 2 at a 45-degree angle, this height is going to be the square root 2. If this is 2, then this height is going to be the square. Is that right? If I have 2 as my hypotenuse, then I have square root 2, because this squared is 2 plus this squared is 2. 4 square root 4 is 2. Yeah, there you go. So that's going to be my y term up there, and we can double check that. So if I have, this is going to be 2 divided by square root 2. So 2 divided by, oh, I feel like that's not going to work out. 2 divided by the square root 2. No, that's fascinating, because my game on rationalizing denominators, I have a hard time seeing that this is the square root of 2. Because I'm going to multiply top and bottom by the square root 2, and that's going to be 2 square root 2 on top divided by 2 on the bottom. 2's cancel, that's square root 2. I just have a hard time seeing that. 2 divided by the square root 2 being the same thing. All right, hell yeah, let's double check this. And so this is going to be 2, because a and b is going to be 1. You know, I'm just trying to simplify this so I don't make mistakes. So we have 2 plus 2 square root 2 divided by the square root 2. And that term is going to be a distance of 3.4. And that's kind of what we should expect. We have 1, 2, plus this, and then this term was going to be the square root of 2. So we have 2 plus the square root of 2, which is that term. So, I mean, even that 45, it took me a while to get used to, especially since if this is a height of 2, it's going to overtop. If this is a height of 1, this height is this height, and a 45-degree angle, just visually, this point A is going to be farther than point C. And again, this is the graph of it. Is that this is B, a unit of 1, and then this line at a 45 passes that point. This one's going to be square root 2 or 1.4 out, and then this is just 1. All right, hell yeah. So now let's get on with the hardest part, probably. What we're going to do is we need to compare this distance with this distance. So you want to do the easiest one is just, hey, Pythagorean's theorem on this. This is XL and YL. So I'm just going to take this squared plus this squared, square root that, and then cool. And that's going to be that distance. And we just need to check it with this. So let's do the harder one first. Using Pythagorean's theorem, I can't just take this value for xe because that's all the way from the origin. You know what I mean? So I need to take this value of xe, which is out this far, and then subtract it from this value of Lx to get that distance. So that's what I'm going to do. So I'm going to have, and then are my denominators the same? Like even right now, I'm going to subtract these two. I'm going to get this with a common denominator. So I'm just going to put a 3 downstairs, and then for sure have to FOIL in a 3 upstairs. Sorry, 3. So let's subtract these two. So I'm going to have 3a divided by 3 square root plus, I'm sorry, 3 times 2 is 6. I'm going to have 6a divided by 3 square root plus 6b square root divided by 3 square root. Now I'm going to subtract it from here. I'm going to subtract 2a divided by 3 square root. See, I just want my denominators to be the same because I can only add and subtract. I call this oranges. Hey, this is something funky, but hey, check it out. I've got 6a oranges plus 6b square root 2 oranges plus 2a oranges. You know what I mean? Or you could say, hey, the square root 3 indicates a fruit. You know what I mean? Maybe not a vegetable. If I had, you know what I mean? But anyway, and then I have apples, and these are oranges. You know what I mean? I have six apples. That's what the A would be. This indicates fruit. So we all have, everything's a fruit. And then we have 6 apples minus 2 apples. And then we have 6 oranges. And let's see what we're, so anyway. So I had these two terms, and then we're going to subtract. So yeah. I had x of e, and then those two terms right there, subtracting x of L. So so I'm 2a divided by, yeah, and then I'm subtracting 2b square root divided by 3 square root. But even though these square roots could cancel, again, I just walked through that whole process. Hey, these are all the same. You know what I mean? Everything's, you know, something funky, so I can add them. You know what I mean? But when it gets down to it, hey, I have 6 oranges minus 2 oranges. So I'm calling, you know what I mean, kind of that term an orange. I'm calling this term an apple. Cool. And hell yeah. And they're all in the same produce aisle. You know what I mean? If these weren't the same, you got to get them in the same aisle. I don't know. I think it's good to use kind of like a nomenclature like that. It really helps me if I'm adding. I just want to add. If it's funky, I just want to look at this and be like, hey, I got 6 apples minus 2 apples. So now this was XE minus XL. Part of our distance equation, distance between L and E, is going to be the square root of XE minus XL squared plus YE minus YL squared. So that's the equation. What we're doing is just this part right here. Cool, so let's continue on. I'm going to have 6 minus 2, that's going to be 4a, 3 square root. And then I'm going to have 6 minus 2, that's going to be 4 b square root divided by 3 square root. Cool, so that is that term. And I think we can move on and do this YE. So I'm going to do YE minus YL. Okay, that was way simpler. So we have 2am. Well, we need to get the denominators the same. So I'm going to say this is 6am divided by 3 square root. See how this is 6 divided by 3? That's 2. 6 divided by 3 is 2. So that's... Okay, and then I'm going to subtract it from 2am 3 square roots. So hell yeah. In the same aisle, these are oranges. The AMs are oranges. 6 oranges minus 2 oranges. So sweet. So I have 4am 3 square root. So this is this term. So we're going to square this term and we're going to square this term. And then we're going to add them. Alright, hell yeah. So we're on a roll. It's just fascinating. This took me like 2 days, 2 nights of just kind of just really slowly slogging through. But it's fascinating. The second you go from like point A to point B, it's like then you can see the hiccups along the way. But it literally took me 2 nights of just kind of making mistakes and just slowly like finding ways to cancel things just a little friendlier. But yeah, so I really enjoyed this problem. Hopefully we don't mess it up. Alright, so this is how I do square root. I'm going to say, hey, it's this term squared, and then this term squared. You know what I mean? Because if I do this squared, I'm going to have that term plus that term. So I'm going to have, these 2 terms are the same. I'm going to have this squared, right? And then at some point I'm going to FOIL these 2. This is going to be squared. And then I'm going to also have, you know what I mean, this times this, and then this times this. So I'm going to have 2 of those terms. So this is how I do anything when I get this squared. I'm just going to square this. So I'm going to say this is 16a squared divided by 9 square root squared. I'm still going to keep this as a square root, you know what I mean? I don't want to mess with that right now. But hell yeah, everything else I squared. And then so we're going to have this squared. So we got plus 16b squared square root squared 9 square root squared. And again, I'm not simplifying this because my denominators, I might be able to add things. Cool. Alright, and then I have that third term, which is, well, there's 4 terms, but you know what I mean? It's this times this plus this times that. So I have 2. So I'm going to say it's going to be like, and sometimes I just write this out. I'd be 2, 4, 4, but we can be 16, 32. I can write that out. So I can just say 32a times b square root, and then the denominators will also multiply. So hell yeah, so that's that. And now I'm going to add it to this squared, which is 16a squared m squared 9 square root squared. And so do I have any a squared m squared terms? No, I mean this is what it is, you know what I mean? And kind of a nightmare, but this would be the square. This is this, and this is my distance LE. Okay, so that's the nightmare one, and we're going to see if it even jives. But hell yeah, it'll jive. And so let's move on to this length. We want to know what BL is, because it wants to compare the length BL with EL. So we just found the length EL. I'm calling it LE, I guess. Alright, hell yeah, so we do the same thing. The distance to BL is going to be the square root. But instead of saying, you know what I mean, instead of saying XL minus XB, well, XB and YB is 0. It's the origin. You know what I mean? So those terms cancel, and you're just left with xl squared plus yl squared. So sweet. So I'm going to have xl squared plus yl squared square root. And let's do it. So I guess we're going to square this. You know what I mean? Which, this, let's kind of get it halfway decent. This is going to be 2a divided by 3 square root plus 2b square root divided by 3 square root. I think that's a little bit easier to see, and we're going to square that. So I'm going to have a 4a squared divided by 9 square root squared. I'm going to square this term. So we're going to have a 4b squared square root squared divided by 9 square root squared. And then I'm going to have that third term. You know what I mean? There's 4 terms, but it's this times this times this. You're going to double it. So I'm going to say 2, 2, 2. So I'm going to say, hey, I get 2 of those terms. 2 times 2, you know, is 4. And then a, and then I'm getting a, and then a b, and then a square root, and then divide by 9 square root squared. Sweet. So this is plus 8ab square root 9 square root squared. All right, and then that's it. We did one of the terms squared plus... Oh, no, that was just xl squared. You know what I mean? Now we have to square this y term. So and that's fairly easy. We just got 4a squared m squared divided by 9 square root squared. Hell yeah, and take the square root of it. So this is the distance BL. So now how do we compare these? Because it's like, hey, prove that this one is twice. Well, we can factor out the denominator. Because the denominator is the same, it's literally like saying, like, hey, this term, these 4 terms, you know, added, and then it can just have one denominator on the bottom. And then you can do this, the square root of the top and square root of the bottom. And if this is just one term, and again, you can even split this up. This term down here is a product of a couple things. So we're going to have square root 9, and then we're going to have square root of square root squared. So if I have, well, that's kind of confusing. But I mean, this would be the same thing as 3 squared square root of square root squared square root. And so, well, you're just left with 3, and then you're just left with the square root. So sweet. So yeah, when you get this bottom the hell outside, you say that, hey, square root 9 is 3, and then the square root of square root squared is just that square root. So hell yeah. So this bottom term minus a square root or anything is just 3 square root. That's how you got that term out of this gigantic square root term. Same thing over here, you know what I mean? Hey, I can get that 3 square root out, and now just the tops. So now these 2 terms have same denominators, and now I just want to know if this top, are these terms twice? Are they 2 times these terms? Well, I can play that same game. If I have a 4, if I say, hey, if I take a 4. And then multiply by those terms and square root. I would square root the 4 and then square root that. Cool. And if I did that, then this square root 4 would be 2. And then if these terms are the same as these terms, then I'm just good to go, because that is a multiple of 2. So that's how you can visually see that if this number is 4 times this number, then what I would do, you know what I mean? So let's write this. So this is going to be, I'm going to factor out a 4 everywhere. So I'm just going to factor out a 4, so I can do that. And this is going to be 4a squared plus 4b squared square root squared plus 32 divided by 4 is 8. So we have 8ab square root plus 4a squared m squared. All right, hell yeah. And I still have to take the square root of this entire top thing. The bottom, we already took the square root. It's just 3 square root. Cool. But now this, you can see that it's the same thing as square root 4 and then square root all that stuff. And this square root 4, all right, hell yeah. And the square root 4 just becomes 2, and then you have all this stuff still in there. But now you can see that I have you know, kind of a multiple of 2. 2 times all this. Denominator is the same. And what do I have here? A 4a squared. A 4b squared square root squared. 8ab square root. And, you know, are you comparing it? So check this out. So we have a 4a squared, 4b squared square root squared, 8ab square root plus 4a squared m squared. So those terms are the same as these terms, and we have a factor of 2 for the length. And I knew I could do this. I just didn't know how much of a bear it was going to be. You know what I mean? I really wanted to spend way more time. If I did a second video, I'd be like, well, how was I able to do this without making mistakes? Because it's not that impressive. I think I do think it's impressive. I think it's very difficult. Like math and physics, especially difficult math, like long math problems. Not difficult ones, but just long. You know what I mean? Your terms can get so messy, and the second your terms get messy, you lose motivation and you start making a mistake. You make one mistake, you're hosed. And so it was just fascinating. You know what I mean? I briefly went over setting a slope that I was comfortable with and showing that, hey, I had those values that I could double check. You know, so if this is my equation for x of L, well, I could set b is 1, a is 1, slope is 1, and then I could confirm that is true. You know what I mean? So that's what we did. But hell yeah. And so I'm really satisfied with this. And you know, I just did this problem. I just completed it about, you know, 15-30 minutes before starting this video. So it's totally fresh, but I'm very impressed even with getting through it. I think this was under an hour. And I was able to actually not make any mistakes. And even show you that process of like, hey, if we did make a mistake, we would have found it, and then we could go back and then track it down. But yeah, just cool. I mean, just kind of a cool proof where you can see that, hey, this is twice. Like this length is twice that length. Because all the terms are the same. I don't know, you know what I mean? So that was pretty cool. Just using equations for lines. And I guess I just ended with this. Why this is cool is because I set the slope of this parallelogram. This problem, and like most problems, will have limits. They'll say, hey, this problem is going to be a parallelogram. It means that these two lines are going to be parallel, and then these two lines are going to be parallel. For this problem, these lengths can be anything. You know what I mean? But because it's a parallelogram, if you set the length of BC by, I don't know if the word is congruency, or just where you have parallel lines, AD has to equal BC. That's why this problem, you know, from a proof perspective is very simple, because you're like, okay, this length is equal to that length. And, yeah, I made the video of going over it. I'm still not, like, super solid of, like, what proves what. But, I did have to start with this triangle first. If I labeled this A and this B, I said, hey, this triangle compared to this triangle have similar angles. And I think that's how I made the jump. And yes, because this is the midpoint, this has to be 2A. And because these are parallel lines, these have to be 2A. So that's the first jump. I took this triangle, said this was A. Took this bigger triangle, said this was 2A. These have all the same angles, so everything gets boosted, you know, twice as much. So if this length, so this length is half of this. So this length is twice from here. What they want to know is, no, that's not true. No, like, holy Toledo. So what, this, wait, no, this triangle right here has this side, and this triangle right here has this side. So this side is twice. Oh yeah, that's where you prove that this length is twice this length. And then once I know that this length is twice this length, then I can look at these two triangles, this small one and this small one. So, and then I can say, hey, this angle is similar to that angle because of this Z shape. I can say that what other angles of this triangle? Because I'm comparing. Oh, and these two angles are the same. Yeah. So if these two angles are mirrored, and this angle is similar to that angle, well, every angle in a triangle has to be 180. So if I know two angles that are similar of two triangles, well, we know the third angle. So these two triangles are similar. This length is double this length, so that therefore every side that's similar has to be double. You know what I mean? So this length is double that, and this length is double that. And you know what I mean? You just have to orient your triangle. So if this is that angle, I take this and then shove it up there, and then so if I do that, this base would be along there, and this length would be along there. Yes, so that means that this length would be twice this length. All right, so hell yeah. So I need to get better at doing that problem, but this was pretty sweet because what we did is we showed it from an equation-based perspective that you can take any, you can set up, this length can be anything and this length. So basically any A, any value of B, and any slope of this, you're going to find the distance between L and E and B and L to be the same based on this equation. So this equation shows that the distance from L to E is twice the distance from B to L. Hell yeah. Thanks for joining me, and that's a video.